Hi, we're going to talk a little bit today about signal flow. You kind of have to bear with me through this as I'm going to try to address some real simple ideas, and maybe I might kind of drift on us into some complex or signal flow issues and electrical flow issues that may or may not be directly related to signal flow the way you might understand it or someone might explain it to you. The first thing about signal flow is that very simply understanding where your electricity and your signal is going. One of the biggest reasons for that, two reasons that you'll find that will be very obvious. The first reason is if you have your signal going a lot of different places, or you have a lot of different signals you're dealing with and trying to keep track of where they're going and the signal flow of, where the path of that they're on, so you know where things are at. And that's a real simple concept of understanding the signal flow and the path that it's following. The other thing, it can get kind of complex because the other aspect of signal flow, put simply, is you've got some kind of knob here or meter or a button or anything that might be in a processor or in line as it's going along on through the signal flow and the path that it's following, to understand what's happening before it, so that you know exactly if it's hit this EQ before this or after something else, so that you know where in the chain along the path that the electricity is flowing, the signal. And it's very simple. It's not any more complicated than that. It's that simple. A whole lot of the issues dealing with that can be complicated, but if you take it one step at a time and look at it that way, that basically you are trying to map out the signal flow and map out its path, so you've got a real good understanding of what's happening. Now that can be the signal flow inside of some type of processor, some hardware processor or some software processor, the signal flow outside or between processors, connectors, anything that the electricity in that signal may be going through or getting channeled somewhere else, looped and coming back, what's happening to the signal and the signal flow when it takes off in some other direction and comes back, that you know what exactly does that mean, and what has happened, what am I seeing when I'm looking at some type of monitor device somewhere in the path of the signal. And so that's a really simple way to look at it. And it basically, from, if you're a simple example, from the guitar, all the way from the pickup, to, a finished product in the DAW or whatever you're recording onto, the whole signal flow, what it's going through. I mean, every resistor, capacitor, and everything can be a micro way to manage that and view that, but all those things can be very pertinent, because that if you've got some type of processor, that you've some type of external hardware compressor, that it's part of your signal flow, but you've mapped it out and you know the signal flow inside of it in the hardware, that you understand because of some components that it may be doing something to the signal that you don't want in the lower end. And so after that, on the next part in the path in the signal flow, that you might want to put some kind of low pass filter on it. That is very generalized idea, and that's one reason why that you might want to understand the signal flow through some hardware a lot better, and an example to just give you some kind of idea of, you may run into those things while you're tracing your signal flow and understanding the signal flow and what's happening inside of a processor. That's a very simple way to see it. And you can tell just by looking at this, if you look at this for a few minutes, just looking at it and understanding what these parts are, that anything can affect the signal flow also. Any knob, any button, anything, any plug-in, anything that you might be touching on the outside of the hardware, or any monitoring device on the hardware, anywhere in between that, can, when is the signal hitting that, and those can affect it. And so that's a real simple outlay of basic signal flow that can get very complex, because signal flow can be very complex, depending what all you're running through. If you're running through huge amounts of hardware and you're in a big studio or a big production or live show or anything like that, the amounts of hardware and the signal flow, pathing it and understanding where it's going can be very complex. But a basic signal flow chart like this, that it's basically not mapping out what's the signal flow inside of the hardware. It's basically worried about from one processor to another. So, or where it's going. Does that make sense? So that you know when it's taken off to left or right or somewhere else, and you have a really good understanding of where everything is going and why. Does that make sense? So that's a real simple explanation. More complex things can be understanding the signal flow when you get into circuitry, because circuitry, real simple. You've got an ADC here. And you know what's happening to it, what's happening, with the signal flow as it goes through, and you've got buttons here, knobs here, wherever, that, what exactly is happening to the signal while it's going along that path. Any resistor, capacitor, anything, if you understand anything about that stuff, any resistor, capacitor, diode can affect that. Amps, switches, any of that kind of stuff can really affect what's happening with the actual components, with the inductors, different types of inductors, different types of transmission lines that are lossy or lossless, grounds, voltage sources, alternating current and direct current, and then monitoring devices for amperage monitoring and voltage monitoring. And that can get very complex to where you can get into some very in-depth audio engineering into circuitry. But it's all pertinent, in the signal flow and a micro view of it to understand exactly what's happening along that electricity in that signal's path, so that you have a real good understanding, so you can go pinpoint where there are problems, after every you're trying to pinpoint it. It's kind of hard sometimes in hardware, and unless you really understand audio engineering, to pull the top off and start testing to see what's going on with a resistor or capacitor or something like that, unless you really know what's going on. And a lot of times that hopefully you shouldn't ever have to do that, and you have a problem that you can take it to somebody who's a professional audio engineer to work on that, and you don't worry about that much of the signal flow except for what's coming into it and what's coming out of it, and how you have to deal with something on the back end or on the front end of it. So basically that can be pretty simple. The other part of it can be when you get into the DAW, because a lot of times when you're dealing with the signal flow, that it's going to be the same thing when it gets in the DAW. And if you're one of those kind of people that are completely in the box, that for the most part, as much as you can, that you can run into all kinds of issues. But to test these type of things, that, things like, a spectrometer, a scope, a level meter, and a phase meter, some simple tools to help you pinpoint issues and problems and what is happening to the signal as it goes along your path, is another aspect of why you want to understand signal flow, to go find what issues are, not just to understand what's happening to it. And sometimes in a big production, it can be just, where is that line going? You understand the signal flow of what's happening, but the next step is why. And then for finding issues, what's happening to it as it goes from, even micro all the way down to the capacitors, because basically you take a guitar, for example, that everything from the strings to the way the guy's his technique is, to the way he's holding his pick, to the type of pickups, to the circuitry in the guitar, to each knob and switch, all, and the chords, connectors, and with the wireless systems, everything in the signal flow, where it's going, all those things can affect what's happening to the audio, to the sinusoids and the complex waveform that you're trying to get either out the speakers or recorded. So to understand that simple concept and understand that the complexities that can arise from it, that are very useful to help you find problems. But basically the signal flow concept is pretty simple. And another issue can be when you're in the DAW, it's the same concept. You try to see that the signal where it's going in the DAW the same as outside of the DAW, and to look at it that way of what's happening to it as it goes along its path. And another thing can be when you're mixing tracks together, once those signals are starting to get combined as other tracks or groups, that's a whole other type of signal flow and path when you're mixing and mastering, all the way up to a mastered, piece of music that's been truncated for an MP3 and dithered. What all has happened along its path, and at what point did it happen, so you can monitor it well and understand everything that's happening all the way up until it's the end product on an MP3. So I just kind of wanted to address that real quick. I didn't want to get really super in depth into that because the basic concept is pretty simple. There are a lot of issues in signal flow that can be very complex, and a lot of routing complexities that you really need to read about to understand, and that's going to take some probably reading on your part. I'm going to probably make some more videos that address some of that, but just understanding the basic concept and why you'd want to do that and for what reason, is half the battle. Just understanding what it is and why you'd want to do that, and it boils down to understanding where things are going so you can understand why, so you can go look for problems, so you can find the signal when you need to, so that when you're monitoring it, you know what you're monitoring and at what point in the signal flow and path that you are monitoring something to see if there is issues. And it can even be another micro analysis of looking at an analog digital console. Is the signal flow actually in the hardware, and what's happening, where it's going, getting a flow chart of actually the path of where it's going, the circuitry itself, and understanding what's happening. And so you can a lot better understand the difference between one board and another, and what's happening with different types of circuitry in the signal flow and the path that the electricity in the signal is taking through those things, and how one might differ from the other because of the way the path is, the type of hardware that's being used. And you get a better understanding of what's happening in your software also that's trying to emulate that kind of a system, so that it's doing some of the same things or most of the same things with code. And to understand that can be a huge tool to really help you when you run into issues, to understand what you're dealing with, so that you're much better able to diagnose the problem. So I hope that helped, and I hope that was a very simple explanation that wasn't confusing, and at least to hope that shed some light on that, so that if you go ahead and analyze your own signal flow, that and make a chart of it, that what issues you need to question about, and that where there could be issues and where you need to test, and why you'd want to change the path of their signal flow for some reason, and later on start to investigating why you'd want to change the path, why you'd want to run things different ways for different types of effects or different needs. Those things all arise to try to make you to get a signal flow, so that those issues, your signal flow is set up so because of those issues, because of why those things happen and why you'd want to do that, is the whole reason that you'd want to understand the signal flow, so that you can pinpoint the areas where your signal is at to deal with things or to do things that you want to do along the path of where the electricity in the signal is going. So I hope that was enlightening a little bit, and that it was very basic and very easy to understand, and I hope you enjoyed the video. Peace, hope, love.